Okay, welcome everyone. Thank you for joining us today's Minitab webinar. Topic is capability analysis. Okay, I'm Ting. Never late to wish Happy New Year to all of you and hope this year will be better. Okay, I'm Nur Sulawati and I'm Technical Support Specialist at Visit System. Visit System is an independent local representation for Minitab product and training in Malaysia, Singapore and Batam, Indonesia. Okay, before we get started, I have some housekeeping items. If you have questions during presentation, please type them into the question box in your control panel. You may send in any time throughout the presentation, but I will address them during Q&A session at the end of webinar. Kindly ensure that you have connected to the audio via your computer speaker. Please fill out our survey before you exit the tab. This survey will help us to improve the quality of our upcoming webinar. For your information, this webinar will be recorded and therefore it will be set as listen only mode to avoid interruption to the audio recording. The recording will be accessible anytime later on our website www.visit.com or by subscribing to our YouTube channel Minitab Malaysia and Singapore. Okay, Minitab was developed in 1972. We just released Minitab Statistical Software 20 in last 22 October 2020. Okay, for those are new with Minitab, we are statistical software where everyone can use, whether you are statistician or non-statistician or you are data scientists. Okay, Minitab Statistical Software deliver business and predictive analytics and pair with the essential visualization and enable to data-driven value creating decision making. So for the new version, we now from everywhere on the cloud. Okay. So Minitab offer various type of analysis, which is for the quality purpose. Let's say you want to do measurement system analysis like gauge R or linear study. You want to assess about your accuracy and precision, or you want to know your process, is it stable or not stable, in control or not control. So you can go for control chart. We have more than basic control chart. Okay, and then for today we focus on the capability. So in capability we have a two way. Basic one is the way. After this we can explore what can Minitab help you for capability analysis. And then for reliability engineering, we have also like distribution analysis. You can go for the profit analysis, or you want to have a MTFP and for accelerated life testing, or you are coming from R&D background, so you can go for the design of experiment. We not include only for factorial design. We already have response surface method, or we also have a Taguchi method. And then inside the DOE, we have a features like min plot, where you can get which level is most important or optimized to your uh, output. We also provide like something like power and sample size. And then if let's say you are coming from business analytics, or you are a big data person, maybe you are familiar with the correlation, or we also have like something like machine learning or unsupervised, let's say for multivariate PCA, principal component analysis. And then for new enhanced in the Minitab, we already have predictive analytic model like CAD, classification and regression tree. Okay, applicable for regression or for classification. And then we also have the time series analysis is up to the ARIMA model. And then if let's say you are coming for process validation, we have in the process validation, we have a three-step. We have process design. We also have this kind of the features. We have a process qualification, and then we have a continuing process validation. Okay, so this one is some organization using Minitab Statistical Software. And then for information, Minitab is not limited to the manufacturing only. We also have a customer from the services for logistic, and then we also have customer from the service industry. Okay, like say for academician, also using Minitab as their software. Okay, and then the main agenda today, we want to explore what is the capability analysis, when to use, why you needed have a capability analysis, and then how to run capability analysis using the Minitab. And for information, in Minitab, we have a two-way to represent the capability analysis, whether you are using capability analysis or you can using our flagship tools like capability Sixpack. And then if let's say we have more time, I will cover for the capability non-normal and then some features inside the capability analysis in Minitab. Okay, so overview understand the process is crucial part for any organization to gain maximum profit. The first step is to make sure your process is stable. I think if let's say you are familiar with our webinar, I will cover last month about the process control. Okay, once your process is stable, you can use statistical technique like today capability analysis to see if the process is capable and the consistent meets your customer standard. Okay, so what is the capability analysis actually? Capability analysis is evaluate how well your process meets a set of requirements that is defined by specification limit, which is you imagine now this one is your process, this one is your specification. So you want to uh, uh, evaluate your process, is it in the specification or not. Okay, so when your process is centered and they well within the specification limit, is more capable and consistent producing the product that meets customer expectation. So if let's say you're looking for this graph, another side is this one is not capable since they outside from the specification limit. Okay, so when to use capability analysis? So when you want to take in deliver of new process equipment, maybe before you approve new installation process equipment, or as a production begin to establish capability of the equipment, okay, or ongoing basis to verify continuity capability, or once you have notified that out of specification condition. So major of our customer using the CPCPK once they realize that went out of specification condition. Okay, and then why you use the capability analysis? Capability analysis maybe will help you to choose which vendor is consistent, provide superior quality parts. So as we know, you are company and then you have a customer, so you have the vendor for each of your product, so you want to compare which one is a complete, which one is a good one, so maybe you can using capability analysis. And then if let's say you will have something like, is it the variability in the process low enough to consistent provide a part that fall within the specification limit, or does the process need to be shifted to operate more effectively within the specification limit? So this one is a maybe you needed the capability analysis. Okay, so before we go further, is this one is crucial part. Term to term is you need to define first and understanding first before you misunderstood about the control limit and the special specification limit. Sorry. Okay, for the control limit is calculate from your process. So if let's say you doesn't have process, you meaning that you doesn't have the control limit. And then for the specification limit, you have defined by your customer or defined by your design. Okay, so in control limit is what is the process is doing, but in specification limit what we want the process to do, and then for the control limit basically we call it UCL and SCL. So US is upper control limit and lower control limit, but for the specification limit is upper specification limit and lower specification limit. This one is important before we go further, because sometimes our customer have a confusion about the control limit and specification limit. Okay, so this one is the how to run capability in Minitab. We have a two different method, which is we call it capability Sixpack and capability analysis. I think I go to Minitab first. Okay, go to Minitab first. Okay, so where you can get the capability analysis, you can go for the stack, you go for the quality tools. Inside there, we have a capability analysis, we have capability Sixpack. Okay, so we have a two-way, whether you can using capability analysis or capability Sixpack. But it's the same thing. Before you go further, which one you need to know about your data type first. Is it your data continuous or attribute? Continuous, something like you do the measurement, something like the length, your diameter, your temperature, maybe your speed. So something like numerical data. And then if let's say your data is attribute, something reject, accept, or defective, you can go further, binomial or Poisson distribution. But for information, if let's say you are continuous data, you have needed to go another stages, whether your data is it normal or your data is it non-normal. Okay, so you need to identify the distribution first. Since go for the capability spec with the normal data set and then non-normal data set before you get calculate your CP or CPK value. So the first step, you need to know what is your data type, whether it's continuous or attribute. After that, you need to know if let's say are continuous, whether your distribution is a normal or non-normal. And then after that, you can go for the calculate for the CP/CPK. So here is something differences between capability spec and capability analysis. But I will stress again after this because we need to know what is the CP, what is the PPK, something like the index in the capability analysis. Okay, so maybe this one is two assumption you need to follow before you calculate the CP and CPK. Okay, this one is you need to have some assumption your process is stable over the time, and then the second assumption is you need to assume what is distribution is a fit to your data. Basically, we have a normal distribution or we have others, we call it non-normal distribution. Okay, what is we consider that process is stable. So process is stable or in control is in which the key process response and the product property show no signal of special causes variation. And then if we consider that our control have a both common and the special causes variation. Okay, so let's say you have a control chart. Okay, you have control chart. So some of your process data outside from this line control limit, whether upper or lower or something like you have a pattern inside this one, so you need consider that the process is out of control. Okay, so this one is how you can evaluate your process is stable or not stable based on the control check. And then another way, another assumption, okay, second assumption, you need to have assumption distribution, whether it's normal distribution or non-normal distribution. So if let's say you want to check is a normal or non-normal, so you need go for the histogram. Okay, you need go for the histogram. Okay, so this one is the uh, data. So whether you need to have a hypertesting, whether it's hash null and then hash alternative. So in the Minitab, we provide this analysis to do the normality test. I will show after this. Okay, so in your mind right now, you need to have a two assumption. Is the process is stable or not stable? And then the second part is the assumption, your distribution part. Okay. So we have another term, maybe this one is a capability index. Okay, a lot of type of capability index in industry. Okay, but most of our customer using CPK, and PPPK, but others I have something like they using Sigma level, or they using a DPU or DPMO, or they also using the PPM. So this one is based on your preference. Okay, but today I just focus on these indices only, which is we call it potential within capability, and then we have a process performance overall capability, which is we have a CPK, and then we have PP and PPK. So which is CP go for the short term, okay, and then for the PPK go for the long term. So in term short term, long term, in term of you have something like between within subgroup. Okay, you have a between and within subgroup. So this is a potential capability. This one is we consider that the process performance. Okay, your overall capability. Okay, so we go for the first one is a potential capability. So this one is the how we can get the CP and CPK. Okay, the potential capability is associated with the within subgroup standard deviation. Okay, so this one is I think major of us already know the standard one is 1.23. So if let's say more than 1.23 is highly capable. So maybe the action you no need to do nothing or reduce specification limit or no need to do the inspection. If let's say your CP or CPK more than 2 or more than 1.33. So if let's say your CPK less than 1, we consider that the process is not capable. So maybe you need do some improvement, okay, maybe by reducing the variation. So depends on your problem, okay. And then if let's say is equal to 1, we consider that is marginally capable. So do nothing for this one, but depends on the sample size. Maybe you want to improve more, so you need to go for the improvement. Okay, and then sometimes we confusing about the CPK when to using CP and CPK. So if let's say it's a CP almost same with the CPK, meaning that your process is centered between the specification limit. If let's say CP or CP not same with the CPK, so process is not centered. Okay, so CPK is all about your uh, location. Okay, so if let's say you see here, you see uh, the formula for get the CPK is we consider that is a minimum number between lower and upper, so you can get. Okay, so same go uh, for the PPK, we call it process performance. Okay, overall capability index are associated with the overall sample standard deviation. So this one is same but different. This one is overall. Okay, so this one is a weighting. So the differences between PP and CPK. Okay, the justification also the same. Okay, less than one is not capable, more than one is capable, more than two is highly capable. Okay, more than 1.23 is capable. Okay, so this one is the differences between process potential and then process performance. Okay, so in the potential we have a CP and CPK. For the process performance we have PP and PPK. So for the CP basically we respect to the subgroups. Okay, subgrouping. For the PPK we go for the whole process, and then from the CPK how well your process could perform, and then for the PPK we consider that is actual performance. Okay, and then this one is we call it short term, this one is a long term, and then here is calculate for normal data only for the CPK. If let's say you go for the non-normal, so you can get the PP and PPK only, doesn't. Okay, for this one. Then so here I have one case study here. Okay, an engineer manufacturer use a forging process to make piston ring. The quality engineer wants to access the process capability. They collect 25 subgroup of 5 piston ring and they measure the diameter. The specification limit for piston ring diameter is 74 plus minus 0.05. So I go to the case study. Okay. Okay, go to the case study. Okay, so we have one case study. Okay, so this one we have 25 subgroup. Okay, 25 subgroup, and then every sample, as every subgroup we have a 5. Okay, 5 observation, meaning that we have now subgroup size is 5. Okay, so where we get the capability analysis, you go to stat. Okay, you go for the quality tools, you see that capability analysis. Okay, I will show you. Okay, go to stat, go to quality tools, go to capability analysis. I choose normal. Okay, I choose normal. But you need to remember again, we need to fulfill the assumption first before we go for the capability analysis. Okay, so I go this one. Okay, so here we need to go for this one first. If the process is stable or not stable, and then you need to assumption before you get started with the capability analysis. So I need to show get the control or not control first. Okay, so where you can get, go for stat, go for control chart, go for the subgroup X bar chart. Okay, so here is at our diameter, so our subgroup is a 5, and then you click OK. Okay, so based on this control chart, doesn't have any point, any sample outside from the control limit, upper or lower, both side for mean and then for the range control chart. Okay, and then maybe doesn't have any pattern here, so we consider that the process is stable in control side. Okay, so another assumption we need to know about the distribution. Is it this process data normal or non-normal? So I go to stat, go to basic statistic, and then you choose normal test. Okay, so from here is a diameter. So in this one is a basic one, default setting. We using the Sun Darling, but maybe you are familiar with the other normal testing like RJ or Comgrowth. You can go for this. testing. Okay, so but I just proceed with the default one, AD, and then click OK. So now you get this one, and then p value is more than 0.05, and then we consider that this data is a normal distributed. Okay, so we have a two here. First, our process in control, and then the second part, our process is a normal distributed. So now time to us, okay, get the CPK value, PK value. Okay, so go to stat, go to quantity, go again, capability analysis, go for normal. So inside here we have a diameter. Subgroup size is a 5. Our lower is a 17. Okay. Okay, and then you click OK. So now you get the process capability report for diameter. Okay, I will do again. Go to stat, go to quality tools, go to capability analysis. You choose normal, and then you include all this one, your single column, your spec limit, and then you click OK. So now you get the process capability. So from this one, you see that your process is centered. Okay, it's centered, right? And then based on this indices, PP and CPK more than 1.23, so we consider that the process is a capable. Okay, so this process is a capable, so no need to the improvement. So if let's say you want to go higher CPK, okay, more than 2, maybe you need to have something simple improvement on it. Okay, so if let's say you doesn't using CPK, you can go for the PPM or for LSL. Okay, so compare this one. So this one is how we done capability analysis using the Minitab. Okay, this one is a first method. Second method, I use the same thing. Okay, same case study here. Okay, same case study, but different method. So go for the stat again, go for the quality tools, go for the Sixpack. Okay, I choose normal since we already checked our process data. So go for the normal. So I go for the diameter. Here is a 5. Okay, and then you click OK. So now you get 6 pack. 6 pack meaning that 6 picture in one graph. Okay, so in the 6 pack, we already check. Okay, your process is control or not control based on the control check here. And then the normality distribution, is it normal or not normal? And then here is a capability historical. And then here is a capability plot. So which is we are already check the assumption. So maybe if let's say your customer request, is it your data, is it normal or not normal? Okay, so if let's say you using capability 6 pack, they already know your data, is it normal or not normal. So this one is the differences between two of these method. So here is using capability 6 pack, here is using capability analysis. The same thing, but different uh, layout only. Okay, so we have here, we also already here. Okay, so we have a two-way to do the capability analysis. Okay, the major one. Okay, so another portion here, we do again for the capability analysis, maybe go for the stat, quality tools, go for the 6 pack, normal. Again, you get here, okay, and then you can get the capability 6 pack. Okay, so from here, okay, to this here. Okay, sorry, so here is the differences between capability spec and capability analysis. So maybe if let's say you the one use show your assumption, so you can go for the capability analysis. If let's say your customer requests your assumption before they looking for the specification, so you can go for the capability spec. Okay. Okay, so we have another case study. So the quality engineer at the company that manufacture flow tiles investigate customer complaint about the wrapping in the tiles. To ensure production quality, the engineer measure wrapping in 10 tiles each working day for 10 days. So the upper specification limit is 8 mm. Okay. So for the non-normal data, we have two approaches to the perform of capability analysis. The first step, okay, the first one is you can select a non-normal distribution model, fit your data, and then analyze the data using the capability. Or another method, you need to transform the data. So the normal distribution is an appropriate model and use the capability analysis for normal data, such as is normal capability analysis. Maybe you already transform your data and then you can go for the normal capability analysis. So I think I go to the case study. Okay. Okay, so another case study here. Okay, so we have a 100. Okay, every time they take 10 sample. Okay, so this one is a 10. Okay, so we consider that this one is non-normal data. Okay, if let's say you not sure, you can check it whether it's a normal or not normal. So the same step, go for the step, go for the basic statistic. Okay, go to basic statistic, go to the normal testing. Okay, so here is a wrapping. Click OK. And then you can see that now is the p-value is less than 0.05. So we consider that this process is not normal. Okay, so you cannot go to the capability analysis. So you need solving this problem first. Okay. So from here, we know now it's non-normal. So how? Okay, so we need to know what is distribution for this process. Okay, so go to stat. Okay, go to stat, go to quality tools, go to individual distribution identification. Click here. Okay, so here is our wrapping. So here in the Minitab we have 40 type of distribution. Okay, so I think we use default setting, use all distribution and the transformation, and then click OK. Okay, now you can get all the distribution. Okay, so in Minitab we have 40 this one. So we have a goodness of fit test. So you need to check one by one, which one is the good one for your distribution. Okay, maybe you want to using p-value here. Okay, you can using p-value, or you can go for your graph one by one. So it's considered is a straight line. So we consider that it's a normal distribution. Okay, it's a normal distributed. So for this case, I think it's a wearable. Okay, it's a good one. So if let's say we go here, okay, we go here, okay, we go here. Okay, so you see that is something like we'll go for straight one. This one is not follow the straight line. Okay, so we consider that this data is a wearable. Okay, the first step. Okay, we consider that the data is a wearable. Okay, so go to stat, okay, go to quality tools, go to capability analysis, you choose non-normal, okay. So now it's our ready. So we already only have the upper, okay, and then you click okay. So you can see that this one is a non-normal. So we just proceed with the overall capability only. Okay, overall capability only. So based on the PPK here is a less than 1.23. So we consider that the process is not capable. Okay, the process is not capable. So if let's say you using normal data, okay, this one is a normal data, they provide another information for the potential reading. But if let's say you're using non-normal, they just proceed with the overall capability only. Okay, so this one is the differences between normal data, non-normal data. Okay, so we have another second method. Okay, second method, you need go for the transformation. Okay, so I go to stat. Okay, I go to stat. I choose normal. Okay, so normal. I go to transform. Okay, just okay. So this one I go for transform. Okay, in the Minitab we provide two type of transformation. Whether you want to choose a box score or Johnson. Okay, Johnson is more complicated rather than box score. Box score is simple method rather than Johnson. So based on your preference. So but today I just proceed with the box score only. So I go to box score and then click OK. And then click OK. Okay. So now Minitab transform using box score, and then they provide the probability PPK and then CPK. So based on this value also less than 1.23, so we consider that the process is not capable. Okay, the process is not capable. So I will do go back to stat, go to quality tools, go to analysis normal, and then you choose transform, whether you choose box score or Johnson's transformation, and then you click OK, and then you click OK. So you get the process with the transformation. Okay, so we consider that you using normal distribution. Okay, so that's why we provide the overall capability and potential capability. Okay, or you can go directly to stat, quality tools, capability analysis. You go for the non-normal, and then you need to choose which distribution fit to your process. Okay, and then you click OK. So you get this one. Based on this one is a well-good distribution. Your your PP and PPK is less than 1.3. So your process is not capable. Okay. So it looks like complicated, but the first thing you need to go for the assumption whether is it control or not control. Okay, and then if I got to control, you go for the distribution. Okay, so let's say it's a distribution, normal distribution, you go directly to quality tools and then analysis normal. If let's say your is not normal, so you can go for non-normal, or you can go for normal, but you need to go for the transformation. Okay, but here is depends on your preference, whether you want to using transformation or you want to identify the best fit for distribution. Some researcher assume that using the transformation, you do something like editing, because you something like box score, maybe you have in inverse or you need to square of your process data. So you not need not using the actual value. Okay, but if let's say you fit your distribution to what type of distribution, so during you calculate the PK, you using the real data. Okay, so but this one is based on your preference. Okay, and then another step. Okay, so another features inside the capability analysis, we have a assistant menu. This one is maybe for newest with the statistical method, it may help you. And then if let's say you are expert, also it will help you, okay? Because they give it you guideline before you go further. And then the dialog box also is simplest, and then the result also is more comfortable. Okay, so I go back to this one. Okay, the same thing, this one. Okay, here is our assistant, but not all the in the start menu in our assistant. This one is a frequent our customer using, so we include in the assistant menu. So I go to assistant, you choose capability analysis. Okay, so in this one, they give it you direction. Okay, what is a data type here? Okay, is continuous. What is continuous? What is attribute? Okay, and then here they provide the what your count. Maybe is a defective or defect per unit. And then for this case, we are continuous, so we proceed with the capability analysis. So is here is a diameter. We have a 5. Here is a 7. And then you click OK. So now you get the summary report they provide you. Okay. And then the most important here is this one, this portion is how capable is it the process. Okay. So you can see that here. And then we have the specification limit. Also, we overall capability we already here. And then your capability plot also here is your histogram. And then they have a diagnostic report. Okay, diagnostic report. And here they are process performance report. So this one is more to Z PHPPK. And then here is we have a report card. Okay, the same input but different layout. Maybe is it for the newest, maybe this one is more helpful for you, okay, to do the capability analysis. So if let's say you want to do something like editing, so you just double click here. So you double click and then you just put here, maybe, okay, and then you click OK, and then you click OK. Okay, so for your information, you just right click, you can send to Word or you can send to PowerPoint to do presentation or to the reporting purpose. And then if let's say the new version, you can send to your report site. If let's say you're using this one. Okay. Okay. So this one is the way the features inside the assistant menu button. Okay, so we have a summary report, we have a diagnostic report, we have the process performance report, and then we have the report card here. Okay, so this one is from the assistant. This one is from, okay, this one is a transformation. This one is a fit with the distribution, and then this one is a Sixpack. So we have this one. Okay, so you can see that different layout, but the same thing. Okay, the same thing, just different layout only. Okay, so this one. Okay, okay. Okay, I go to this one. Okay, so if your product is capable and consistently meeting the customer needs, you can move on to the last step to begin the improvement and optimization process. So once your process is in control, the process is capable. So the next stages, maybe you can go for the optimization. So maybe you can go for the design of experiment, okay, to do improvement. Okay, so any question? Okay, any question? If let's say you have a question, you please type into the Q&A session box, because we using the new platform. Okay, if let's say I doesn't have any time to uh, answer your question, maybe after this I will answer by the email. Okay. 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 Okay, so if let's say data is not normal, so you can go for non-normal. Whether we have a two type, whether you want to choose you fit distribution first or you go for the transformation method. So if let's say your data is attribute, you can go for the you can go for the uh, you can go for the stat quality tools. You can go for the uh, binomial and Poisson distribution. Okay, but binomial and Poisson distribution is applicable in capability analysis. Okay, not in the capability spec. Okay. Okay, if let's say you want this presentation, you need to give it your email into this chat box or into the question box. Okay, so how to know the correct or appropriate number of sample? This one, okay, this one is out of the topic, but I just show how to know the number of appropriate of sample. You maybe you can go for the stat, go for the basic statistic, and then maybe you can go for the go for this one. Okay, sorry, you go for the power and sample size. Okay, so you can go for this one. Okay, whether you are two level or two level or three level. Okay, so this one, this portion. Okay, another question. Okay. Okay, so for the basic one, you can go for this. Sorry, for this one, they provide this one. Okay, sorry. In the report card, they provide this assumption. Maybe you go for the process mean and variation are stable, no point out of control. Okay. Okay, so from if let's say your data is not normal, already transformed with the box plot or transformation, maybe you need to go for the fit your distribution. Okay, the best step. Okay, but some things, if let's say you go for the identification here, okay, so you go for the distribution. Okay, if let's say you see that this one, okay, some things here. Okay, if let's say you go for this one, okay, so you see that this one is a good note of this, and then they provide the p-value here. So from here, we can see that this one is a more 0.05. So we consider that the Johnson transformation is the best method. Okay, the best maybe. Okay, but this one is depend on your preference. Okay, so we just provide the solution whether you want to using this method or this method. Okay. Okay, but what I say that we need go for the process control first. Okay, if let's say your process in control, so you go for the distribution, and then after that you can get the CPCPK, because this one is more reliable. Okay, rather than you just calculate the CPCPK without what the situation for your process side. Okay, I think this. Okay, so just wrap up again. Okay, in Minitab we have a three method. Maybe okay, easy for you see that this one is a for three method. Okay, so first one you can using stat, you can using quality tools, capability analysis, or you can using the capability spec. Okay, or you can using the assistant. So different method, you have different layout, but the same thing result. So which is for the capability, we using capability index, whether PPPK or CPCPK or PPPK or DPMU or sigma level. Okay, so this one is for, and then before you get the CPCPK value, you need to have two assumptions. The first one, your process must be in control. Okay, so if let's say your process is not control, so you need to go to investigate what happened, because from the process in control or not control, you can see that, or you can differences between special causes or common causes variation. Okay, so after process in control, so you go for the distribution of your process data. After that, you go for CPCPK or PPPK. So based on your preference. Okay. So if let's say if you want to this material, so you can leave it your email, and then after this I will send the material for you. Okay. Okay. A lot of question here, maybe. Okay. But if let's say I doesn't answer your question, maybe I will go email to you. Okay. Okay. So let's say, okay. So let's say you want to try or buy Minitab 20. Okay, you may visit our website www.minitab.com or www.visit.com, or you can contact us to sales@visit.com or minitab@visit.com, and then you can follow us to the media social like Facebook and link to Minitab Malaysia and Singapore to get the latest event or upcoming event, or upcoming training, or something like tips and tricks, okay, from our media social. And then if let's say you want to access back this previous webinar, maybe you want not clear about the conference chat, maybe you can go or subscribe our to YouTube channel Minitab Malaysia and Singapore to see our previous webinar and or upcoming webinar. And then really appreciate if you fill out our survey in order enhance our webinar session. Okay, so see you next time with different topic, and stay safe.